speed, you should have to limit your data file. So by using global mapper, you can export your data for using in WMS software. So you should have to open your digital elevation model. Okay. Therefore, first you should have to open your digital elevation model data. You can open here. Just browse to your folder in which your global mapper digital elevation model data is found. So just my data is found in software engineering training material, just like GADM. So I should have to open like this. So now you can export your data file or your digital elevation model for using WMS. So to do such, you can go for File, then Export, File, Export, then Export Elevation Grid format. In your case, File, Export, Elevation Grid format. So when I click here, it will be displayed like this. But here the select export format will not be look like this DEM in your file. In your case, it may display like ArcSCD. This one will be displayed. In your case, it's displayed like this, Arc ASCII grid. But here you should have to click in this drop down button and then select them. And then you can say OK, and then also OK, and then here select the vertical unit meter, the vertical unit meter, and then here is the sample spacing. By default, it will show your resolution scale. For example, here it may show 30.5 and 30.5, but by default, before I have selected 10 meter, it displays like this. It's better to use such small numbers to increase your resolution. And also, you should have to select export boundaries, because to reduce your processing limit, you should have to select the catchment area that will represent your. For example, initially I have not created such outlet point, but if you created outlet point, the outlet point will be displayed here. So you should have to select the upper catchment upstream of such outlet point. But here I have not done like that, but your area may look like this, For example, this one is Koga area. Select the draw box like this, and then you can say OK, and then you can say OK the default values, and then give file name. Here you should have to care of. For example, here this PC new volume is software engineering training material. You should have to know where you save, because you are going to open this data in your WMS software. So you should have to select your folder. Here to do such, here it will be displayed like this. So you can go to local disk D, and then you can search for your name. Like here, just software engineering, hydraulic engineering training material. Just I am going to save here. I can say OGA 3, just KG3, and then I can say save. Now it's going to be exported. Now we have exported. So now just let me use WMS file. To open WMS, you can go for start, and then from all programs, you can click on all programs in your PC. But here I can search here WMS. Here I can get here WMS 7. When I click here, it will display like this. So click on WMS 7. Then the WMS software window displayed like this. Quick tour, start using. Just you can cancel. here is the WMS 7 window. Similar to other softwares, here are the main menus: file, edit, display, thin, dim, flood, and window. This is displayed by default. Like other softwares, here are tutors, quick tutor as well tutorials. If you open here, you can get over 300 pages PDF tutorial manual. So you can use this manual. This is very broad software. Here are the different modules. For example, here terrain data module, drainage module, map module, and such like. This hydrologic modeling. When I click here, other things will be displayed here. You see, when I click on hydrologic modeling module, HEC1, models, calculators, hydrograph will be displayed like this. When I click here, it will be like this by default. Even also, when I click on this drainage module, this will be displayed. There are also other things here. Move base module, place contour label, such like. Here is the pan button. You can use this pan button. For zoom in and zoom out, you can use this zoom. And for rotating, and here are to add outlet point. I told you adding of outlet point for your upstream catchment. Here is for creation of outlet point, and here is select node, select arc, create feature arc, and such like features. So now for today's session, we are interested only to do such the drainage module. That means watershed delineation. You can click on this, but just first open file, open. This is a step. Open what? The digital elevation model data. So when you click on open, when you say file, open, it will be displayed by default like this. This is what I have used, the folder that I have used before. But for your case, it will be displayed like WMS below display ሊያደርግላችሁ ይችላል. Therefore, here you should have to go click here this drop down button and then select your folder. For example, for the time being, I have exported before new volume E, software in hydraulic engineering, and then what? Training material. Here, this is the files of type text. You should have to click here and then select all files. Select all files. And then when you select all files, those digital elevation model data and other shape files will be displayed like this. But here I have exported before. For example, here is Ogadem. So you can click on Ogadem file, and then it will open. Just to open. Here is a meter in terms of meter in elevation unit. The other things you can use the default, and then you can say okay. Now it's opening the digital elevation model. Yeah, here is Koga area. So now you can go for dam, and then compute topaz flow data. Compute topaz flow data, and then you can say okay. Here I told you before, current coordinates. Click on current coordinate, and then here select what? UTM, and then here in ellipsoid what? WGS 1984. And then by default the unit will be in meter and the hemisphere, northern hemisphere, and this because we have selected universal transverse Mercator method, and then say okay. And then here also basin areas. For example, square miles, it's too large, so you should have to reduce your units in terms of square kilometer or hectares or acres. It's better to select most commonly hectares, and the distance in terms of meters, and then you can say okay. Now it's going to generate the rivers. It may take some time. When it finishes, this abort will be changed to close. While executing the watershed, here are things: beginning, DEM, input data, input, and DEM pre-processing. Pre-processing means filling of sinks and the like. Beginning, depression and flat area treatment, because when it's going to generate the stream networks, it has observed the depression values in which areas the streams can be generated and say like. So now it says normal program termination, it says close. Now it has finished processing of streams. Yeah, have you seen those things? These are the stream networks. To zoom in, click on this zoom in. When you click on right click, when you right click, it will zoom out. When you click on left click, it will zoom in. And if you are interested to move, you can use this pan. You see, pan. So here, now you can generate your watershed. But what I have told you before, in global mapper, you cannot use outlet point. Here, you can use your outlet point. Here is, you see here, this is create outlet point. When you click create outlet point, the plus sign will be shown like this. Then click somewhere else. When you click somewhere else, have you seen these things? This is X, Y, Z. These are the data values that you have collected from the site. So you can enter your easting, northing, and also what? Z values. But for the time being, I don't have any XYZ value. Just I'm going to use the default values. So this outlet point should have to be on the river. Rather, it will not generate a watershed. So to do such, you should have to select such zoom in. Then you should have to zoom out, zoom in. You see, by default, the river is the outlet point is on the river. So now it can create the watershed. But if it is not on the river, you should have to select. You should have to select this select node. Click on select node, and then you can click and scroll. You see, just I am moving. Just I have moved, so you can move to somewhere else. Your point may be here initially. When you click, it may be like here, but you can go for select node and then click or left click and then move it. Then it will be like this. Then just let me minimize it. Let me minimize it. Now, sorry. Now your outlet point will be displayed like this. Hereafter, you can generate your watershed. Then delineate basin wizard. Delineate basin wizard. Delineate basin wizard. When you click on delineate basin wizard, sorry. Delineate basin wizard, it displays stream feature arc options. Display stream feature arc creation. Use feature point. You should have to check those things, and then you can say okay. Now it's creating the watershed features. Here is the basin area in terms of hectare, the distance in terms of meter, and you can also say create TC coverage. Last time when we were using global mapper, we were generating TC line manually, considering the contour lines. But here it can create the TC line. So I can say create TC coverage. Now you see it has created the TC coverage. Just when you say here delete, okay, it will show you the TC line. Have you seen this? Let me maximize it. Here is the TC line, time of concentration line. This is so now you can save this file here. I don't know whether it tell you the area and the length features. I'm not sure, but to do such area and length features, you can save as, and then here, because just we are going to export, so file, save as, and then here you see file name, for example, kg4 watershed. You should have to give your watershed name, and then here save as type should have to be what? Shape file. It should have to be shape file. Here is. When you click in this drop down button, the shape file will be here. So click on shape file, and then now you can say save. And then here feature points, point shape file, feature arcs, arc shape file, feature polygons. You should have to check all things, and then you can say okay. Just now it has exported. So to know your attributes, you can open these files on global mapper. So to open such, you can similarly file, open data file, and then browse to your folder in which you have saved. So just I have said what? kg4 watershed. Yes, here are three things: kg4 watershed, point, polygon, and arc. I have checked those three things. Have you remembered? I have checked polygon, arc, and point feature. So here, just let me open it, the polygon. Then here is size unknown projection, UTM, WGS, just similar. Now it has displayed here, but since it is a very small watershed, it's not visible. Yeah, the watershed looks like this. If you want to know the area, you can select this info tool, and then you can say okay, and then when you click here, it will show you the area. This is 55,782 square kilometer, or it's around what? 5.6 hectare. That's 5.6 hectare. And to know the river length, here is arc. You can open also arc. You can say okay. Yes, the units should have to be defined. 103 square room. Okay. I think that is not opened. I think the hardware is too small, that's not visible here. So you can open like this, and you can know your attributes. And then you can use these attributes for what? For your analysis. Last time, I think you have seen about how we can determine the peak flood by using what? A Gamble-Powers method. Or also you can use these attributes for what? For HMS. So you can use this area, and then also you can take those TC values from this global mapper, and then you can determine your analysis like this. Even also here are like basin modules, drainage, and so like features. When you click on those different attributes, those things will be displayed like this, and different things will be displayed like this. This is how we can delineate the watershed by using our outlet point, so that you can export this file and you can use for